In the distant year of 1822, deep in the Canadian wilderness, lived Alexis St. a simple hunter and trapper whose life was destined to pass unnoticed. But one day, at Fort Mackinac, a musket shot rang out. Accidental, yet fateful. The shot struck Alexis in his left side, tearing through his ribs, puncturing his lung, and piercing his stomach. It was a mortal wound. Miraculously, he survived. However, a gaping hole remained directly in his stomach, an opening that would not heal. Thus, Alexis St. became an involuntary, unique phenomenon. His body transformed into a living laboratory. His wound served as a window into the very core of the digestive system. It was through this window that Dr. William Beaumont, an army surgeon, was able to peer inside. He conducted hundreds of experiments, fundamentally altering our understanding of the stomach, its functions, and its secretions. He laid the groundwork for a new science, the physiology of digestion. All thanks to one accidental shot and one extraordinary patient. Many imagine scientific breakthroughs as a sudden flash of genius, an epiphany descending upon the chosen few. We are accustomed to myths of great minds in their studies, suddenly exclaiming, "Eureka!" Yet true science rarely emerges from sterile conditions. More often, it grows from chaos, from randomness, from a desperate search for answers to the most unusual questions. Sometimes it demands sacrifices, and almost always it requires persistent, at times relentless, effort. It is not always beautiful, and sometimes, by modern standards, it is entirely unethical. The story of Alexis St. and Dr. William Beaumont is more than just a chapter in a textbook. It is the stark truth of how knowledge forges its path, a story that began with a single shot. Before that shot was fired, before one man's body became a window into the unknown, the medical world was shrouded in deep darkness. In the early 19th century, as in centuries prior, knowledge of the human body remained fragmented, based more on ancient dogmas than on actual observation. Physicians relied on texts by Galen and Hippocrates, written a millennium and a half earlier. Medical practice was a blend of superstition, cruelty, and desperate ignorance. Wounds were cauterized with hot irons or doused with boiling oil, believed to cleanse damaged tissues. Pus flowing from infections was considered a laudable sign, supposedly indicating the body was fighting. Bloodletting, an ancient practice, remained a universal remedy for any ailment, from fever to depression, literally bleeding patients, further weakening them. Internal organs remained a mystery. Their functions were understood only through myths. The stomach? Merely a bag where food fell. Almost nothing was known about its chemical processes, the role of its juices, or the complex mechanics of digestion. Any intervention into internal cavities was a death sentence. Survival after a severe injury was a matter of chance, not a physician's skill. Medicine did not heal, it merely observed the inevitable. In this world where pain was the norm and death a frequent visitor, the understanding of life's most basic processes remained shrouded in ignorance. It was in such an era, burdened by suffering, that the first sparks of true scientific inquiry began to ignite. In this era, where suffering was the norm and knowledge but a faint light, a man appeared whose destiny was closely intertwined with the future of medicine, William Beaumont. Born in 1785 into a modest farming family in Connecticut, Beaumont, lacking the means for a university education, pursued a path open to few. He became a physician's apprentice. For years he toiled over old folios and then in hospital wards, amidst groans and the smell of blood. He absorbed knowledge, but even more, he accumulated questions. Young Beaumont saw what others could not or would not see. He witnessed patients dying from simple wounds, contaminated instruments, or from treatments that only exacerbated their suffering. He observed the best minds of the time cauterizing wounds, bleeding the sick, or administering mercury, all in the name of science, but without the slightest understanding of the consequences. His medical practice began in 1812, when, at 27, he joined the United States Army as an assistant surgeon. The War of 1812 became a harsh school for him. The Canadian border, frozen forests, endless skirmishes. He operated in field hospitals where chaos reigned. Bullet wounds, shrapnel injuries, amputations. Every day he faced a horrifying reality. He saw how theory diverged from practice. Bloodletting, prescribed by dogma, often killed weakened soldiers. Clean bandages were rare, and infections were a death sentence. William Beaumont didn't just follow orders. He analyzed. He compared. He saw that many widely accepted methods simply didn't work. He began to question the very foundation of medical knowledge passed down through generations. This frontline experience shaped him as a physician, forcing him to seek answers beyond outdated dogmas. He didn't just treat wounds, he learned from them. And this readiness for real observation, for direct confrontation with pain and death, prepared him for an encounter that would change everything. On June 6, 1822, at Fort Mackinac, that fateful shot rang out. 27-year-old Alexis St. a simple hunter, collapsed. A musket ball entered his left side, piercing his ribs and stomach. It was a mortal wound. He was brought to William Beaumont. The Army surgeon, accustomed to the most horrific injuries, examined Alexis and delivered his verdict: no chance of survival. He expected the patient to die within hours. But Alexis did not die. His young, strong body clung to life. Despite the grim prognosis, Beaumont set to work. He cleaned the wound, removed shattered bones, and shot. Days turned into weeks, weeks into months. Alexis survived, but the wound would not close. Where the stomach had been perforated, an opening the size of a thumb remained, leading directly into the organ's inner cavity. Liquid stomach contents constantly leaked out. Beaumont tried to close the opening with bandages and clamps, but nothing worked. This was a medical anomaly. Incurable, yet not fatal. Beaumont, observing his unusual patient, initially saw only a problem he couldn't solve. But then curiosity took over. He began to notice something remarkable. Not just food, but a clear, slightly acidic fluid with a distinctive odor was flowing from the opening. What was it? What was its function? Physicians of the time believed the stomach was merely an organ that mechanically ground food like a mill, or at best, a boiler where food cooked under the influence of heat. But this fluid was unlike anything known. One day, while attempting to lubricate the edges of the wound, Beaumont found he had run out of oil. He took a small piece of meat, tied it to a string, and carefully lowered it directly into Alexis's stomach through the fistula. He left it there for several hours, then carefully withdrew it. What he saw astonished him. The meat was not merely softened, its structure had changed, becoming partially dissolved. It had, in essence, digested without any mechanical action. This was direct proof that something far more significant than simple grinding was occurring in the stomach. This clear fluid, gastric juice, was a powerful chemical solvent, actively participating in the digestive process. Beaumont did not stop there. He began a series of systematic experiments. He took various foods, bread, vegetables, fats, proteins, and introduced them into Alexis's stomach one by one. Each time, he carefully observed how long it took for each food to digest and how its consistency changed. He collected gastric juice, studying its properties outside the body. He even placed pieces of food in test tubes with this juice and observed them dissolving at room temperature. This was a revolutionary discovery, disproving centuries of misconceptions. Digestion was not a mechanical process. It was a complex chemical reaction catalyzed by a unique gastric juice. And Alexis St. the man with an open stomach, became a living testament to this truth. He was the key to a new understanding of the human body. Beaumont didn't just observe Alexis's unique wound, he saw an unsolved mystery within it and resolved to act as a true researcher. He didn't rely on old books or authorities, he trusted only his own eyes and what was happening directly before him. His approach was empirical. He asked questions, and he sought answers through direct observation. He took tiny pieces of food, meat, bread, vegetables, and tied them to a thin silk thread. Then he carefully lowered them directly into Alexis's stomach through the unhealed fistula. At regular intervals, he carefully withdrew the samples, meticulously studying how their structure changed and how quickly they dissolved. He didn't just look, he measured, he recorded. But Beaumont went further. He realized that to understand the stomach, he needed to study its juice. He invented a device, a small cup, that he placed at the opening, or he simply collected the drops that leaked out. This allowed him to obtain pure gastric juice, and he immediately began experiments outside the body. He took test tubes, poured the juice into them, dropped in pieces of food, and observed. He varied the temperature. He compared the speed of digestion in the stomach to that in the test tube. This was a breakthrough. He proved that digestion was not merely mechanical grinding or cooking by heat. It was an active chemical process, initiated and sustained by a unique, powerful solvent. Every new record, every new experiment strengthened his conviction. Centuries-old misconceptions crumbled. Beaumont wasn't just discovering facts, he was creating a new method of scientific inquiry, a method based on strict observation, repeatable experiments, and the collection of precise data. This required not only a sharp mind, but also incredible patience and the ability to admit when old ideas proved false. He learned at every step. If something didn't align, he didn't force the result to fit the theory. He changed the theory. His discoveries did not remain in the shadows. Beaumont understood the importance of disseminating knowledge. He published his findings, describing each experiment, every detail, every conclusion. He did so in English, a language accessible to many physicians and scientists of the time, rather than traditional Latin. This ensured his work would be read and understood. He supplemented his publications with detailed illustrations. He didn't just share discoveries, he taught others how to make them. He showed how, armed with only a sharp mind and patience, one could unravel the mysteries of the human body using the simplest tools and the most unusual test subject. His discoveries shook the foundations, but not everyone was ready for this earthquake. The medical establishment, accustomed to the immutability of ancient dogmas, reacted with fury. This was not merely a new theory, it was a challenge to their authority, their centuries-old beliefs. Their voices thundered with accusations. Beaumont was a charlatan. His experiments were barbaric. St. Martin was a victim, held against his will for dubious fame. How could conclusions drawn from a single individual, especially one whose body was so dreadfully disfigured, be trusted? "This isn't science," they cried. "It's a circus, a disgusting spectacle." Scholars who relied on Galen's works wrote angry articles. They asserted that the stomach was merely an organ where food was ground or softened by heat, and that any attempt to peer inside a living person, especially so crudely, was not only unethical, but meaningless. Some demanded an end to the torture of Alexis. Rumors circulated that Beaumont held him as a slave, exploiting the unfortunate man for personal gain. They seized every opportunity to discredit him. For them, it was not scientific research, but a gross violation of all conceivable rules of decency. The very existence of such a living laboratory seemed blasphemous. They could not or would not admit that their dogmas were crumbling before their eyes. However, not everyone was blind to the truth. Some far-sighted minds, especially those who had themselves faced the futility of old medicine, saw a glimmer of hope in Beaumont's work. His publications, written in accessible English rather than traditional Latin, attracted the attention of scientists ready for change. They recognized not only courage, but also methodical rigor. They understood Beaumont wasn't guessing. He observed, he measured, he proved. Among his patrons were influential figures from Army medicine, as well as some progressive physicians who recognized that the future of medicine lay not in old folios, but in direct observation and experimentation. They defended Beaumont from attacks, seeing the real, undeniable results of his work. They understood that beneath the apparent cruelty lay a pursuit of truth that would one day save thousands of lives. It was their support that allowed Beaumont to continue his research despite the storm of criticism. This was a battle for the future of medicine, where on one side lay centuries of prejudice, and on the other, only the pursuit of knowledge. In 1833, William Beaumont presented his seminal work to the world, Experiments and Observations on the Gastric Juice and the Physiology of Digestion. This was more than just a collection of articles. It was a manifesto of new science. Within the pages of this volume, Beaumont methodically, step by step, laid out the results of his decade-long research. He described every experiment, every drop of gastric juice obtained, every change in food immersed in Alexis St. Martin's living stomach. He provided precise measurements, detailed graphs, and illustrations that left no room for ambiguity. His work was not written in Latin, but in plain, accessible English. This was a deliberate choice. He wanted his discoveries to reach the widest possible audience. He did not seek elitism, he sought truth. And this truth, presented with such undeniable clarity, began to pave its way. Beaumont's book became an instant sensation, circulating among scientific communities in Europe and America. Physicians and physiologists, tired of centuries-old dogmas and fruitless debates, eagerly absorbed every word. They saw not just bold experiments, but impeccable methodology. They saw evidence obtained not in dead anatomical halls, but within a living, breathing body. It was a direct window into the workings of one of the most mysterious organs. The old guard, those who had fiercely rejected his work, found themselves isolated. Their arguments, based on ancient texts and speculative theories, crumbled under the weight of irrefutable facts. Their accusations of charlatanism and barbarism grew weaker against the backdrop of rising recognition. Beaumont did not respond to every criticism, he simply continued to publish data. And it was this data that became his most powerful weapon. The former Army surgeon, once called eccentric and monstrous, transformed into one of the most respected scientists of his time. His book became essential reading for anyone studying physiology. Universities across Europe and America invited him to lecture. His ideas became the foundation for further research into the digestive system. He didn't just change the understanding of the stomach, he changed the very approach to the science of life. He showed that observation and experimentation, even if they seem unusual or challenge established notions, are the only path to true knowledge. William Beaumont proved his point not with words, but with deeds. He became an undisputed authority whose discoveries paved the way for modern physiology and saved countless lives. But what specifically changed thanks to this knowledge? What was its measurable effect? First and foremost, Beaumont definitively shattered the myth of the stomach as a mere mill or boiler. He proved that digestion is a complex chemical process. This fundamental understanding immediately impacted dietetics. Before Beaumont, doctors gave general, often harmful, dietary advice. Now they could explain with scientific basis which foods digested faster, which slower, and why. This allowed for the creation of individualized diets for patients with digestive disorders. For instance, in cases of gastritis or ulcers, when the stomach is inflamed, foods that stimulated excessive hydrochloric acid secretion were avoided. Previously, such patients suffered without understanding the causes. Now, doctors could alleviate their condition, if not cure it completely, then significantly improve their quality of life. Treatment protocols also changed. Once it became clear that gastric juice was not just a fluid, but a powerful solvent, doctors began to rethink approaches to treating abdominal wounds. They understood that if the stomach was damaged, its contents could corrode surrounding tissues. This knowledge, though not immediately leading to new surgical procedures, compelled surgeons to be extremely cautious when working with abdominal organs. It laid the groundwork for the development of antisepsis and asepsis in subsequent decades, as understanding the body's internal chemical environment was inextricably linked to understanding cleanliness and preventing infections. The most significant institutional change occurred within medicine itself. Beaumont's discoveries became the clearest example that true knowledge is born not from ancient texts, but from direct, systematic observation and experimentation. This was a turning point. Medical schools across Europe and America began to revise their curricula. Physiology courses, previously based on speculative theories, now relied on proven facts. Students studied the gastrointestinal tract not as an abstract diagram, but as a dynamic chemical laboratory. Laboratory research became an integral part of medical inquiry. Scientists, inspired by Beaumont, began to seek other windows into the human body, developing new methods for studying internal processes. This led to the emergence of new tools, new methodologies, and new areas of research that, decades later, revolutionized surgery, anesthesiology, and therapy. While direct survival statistics from before Beaumont to after Beaumont are difficult to track immediately, his work laid the foundation for everything that led to their dramatic improvement. It was not a sudden salvation of millions, but the creation of a roadmap that led to that salvation. Understanding the chemical processes in the stomach was the first step toward understanding metabolism, nutrient exchange, and ultimately the treatment of diseases like diabetes and obesity. Beaumont showed that the body is not a collection of separate, isolated organs, but a complex, interconnected system of chemical reactions. This new vision became a compass for generations of physicians. They stopped guessing. They began to investigate. And every subsequent step in physiology, from the discovery of enzymes to the understanding of hormones, relied on this breakthrough. He didn't just provide answers, he taught how to ask the right questions and how to find answers using the scientific method. Thus, Beaumont's work did not merely change textbooks. It changed the very paradigm of medicine, transforming it from an art of guesswork into a precise science. And this became the most measurable effect of his decade-long, at times ruthless, but incredibly fruitful research. Their story is not just a chapter in physiology, it is a harsh lesson in how knowledge forges its path. Alexis St. the man whose body became an involuntary laboratory, was a victim, yet also an indispensable catalyst. William Beaumont, driven by relentless curiosity, showed that truth is born not from ancient books, but from direct, painstaking observation. Their shared journey, which began with a single shot, exposed the paradox of science. It can be ruthless, even unethical by modern standards, but it is precisely in this struggle, in this confrontation with reality, that it saves countless lives. It is a reminder that progress often comes at a high price, demanding sacrifices and unorthodox methods. But its fruits change the world forever.